Hello, everyone. We are close to a minute off from getting started. Let's just let more people join, but welcome to the session on containers for better science. We'll have 3 presentations today. Each will be close to 15 minutes long. So we'll have maybe 12 minutes of presentations and then a couple of minutes for questions. We do have a 15-minute session at the end just for general discussion. So that's going to be sort of a mini panel, and then you can ask additional questions then as well. During the talks, please use the Zoom chat for any questions that you want to be addressed right away. If you have more open-ended questions, you can use the Google Doc that's there in the Kiko chat interface, and we can go over them towards the end. So with that, our first talk today is on a serverless gateway for the execution of open machine learning models in AWS. I believe this is pre-recorded, and our presenter will be Diana Maria Rania Delgado. So Abe, if you would play the recording.
Hello everyone. First of all, thank you very much for attending this presentation. My name is Diana Maria Naranjo Delgado. I'm a PhD student in the Grid and High Performance Computing Group at the Universidad Politécnica de Valencia in Spain. My presentation today is about a serverless gateway for the execution of open machine learning models on AWS. The content of the presentation is based on 6 fundamental points: introduction, objective, architecture, use case, demonstration, and conclusions. Deploying machine learning models or artificial intelligence applications on on-premises servers face certain complexities, and servers require regular maintenance and cannot easily be scaled up on demand without downtime. In this sense, serverless computing emerged as a scalable and cost-effective solution to address the main resource provisioning challenge faced by machine learning users. Serverless computing is a completely self-management service in which the cloud provider manages the underlying infrastructure, so developers only need to focus on the functionality of their application. Therefore, the objective of the work is to design a server-based architecture that integrates models from existing catalogs of machine learning models already trained and publicly available with a serverless cloud computing platform. The platform has 3 fundamental components. The BAS API is a REST API written in Python that provides easy access to machine learning, deep learning, and artificial intelligence models. For our case study, it was necessary to develop a command line tool that would allow obtaining the prediction of the model, so we implemented the DeepBus predict command. SCAR is the other component of this architecture. It's a framework for executing containers from Docker images in AWS Lambda to run event-driven applications. SCAR has 3 execution modes through which the prediction can be obtained, using AWS Lambda or AWS Bash. The last of the component is a user interface that represents the front end of the web-based architecture, allow users to obtain the prediction of machine learning models in a user-friendly way. Okay, the image shows the architecture of the platform where previously the administrator, through the SCAR client, create the function with the model to be integrated. Users can authenticate in the web through method, using their cognito credentials if they are deep users of the deep EM provider. Once the user has authenticated with the temporary credentials obtained from AWS, it is possible to interact with the files in the S3 bucket. Once one of the models is selected, when a file is loaded to the bucket, it requires that the function to be activated and the file to be processed in AWS Lambda or AWS Bash as specified in the creation of the function. The resource is stored in the output S3 bucket. The case study is made up of 4 publicly available models. There are 3 models from the deep catalog, an ADO classifier, a plant classification, and a body post detection models. This model does not meet the space limitations of AWS Lambda. Therefore, they will run on AWS Bash. To implement the Lambda execution mode, we decided to integrate the Darner example to classify objects. Now it's time for a demonstration. On some static time, I have recorded a video to adjust it to the presentation time. I will first comment on the administration part for the example of body post detection model. For the creation of the function through the Scar client, two files are necessary. One is the script to be executed within the function, in this case, dpass.sh, and the other is the definition of the function, where it is necessary to specify the name of the function, the execution mode, in this case, the bash, because the image doesn't meet the limitation of AWS Lambda like I mentioned before. In addition, the storage provider for the input and the output files are defined. In this example, we use Amazon S3, where we define the path for the input and output files. To create the function, the command scar init is used, and the configuration YAML file is specified. After a few minutes, we should obtain that the function has been created successfully, like we can see in this part of the video. Okay, now, on the other hand, in the AWS console, we can see the service created through the Scar client with the command scar in. In Lambda, we have 5 functions related to our platform, one for each model, and the scar the pass list job function to check the status of the jobs that are executed in AWS Bash from the web interface. In the AWS Bash service, we can see the job queues of the 3 models that run in Bash, which are the audio classifier, the plane classifier, and the body post detection model. Finally, in AWS S3, there are 2 buckets that are used, one to store the web interface, in this case, ScarDpass UI, and the other bucket is to store the input and output file for each model. Within this bucket, there is a folder per model, and within each model folder, an input and output folder. Okay, now we'll comment on the user part. So this URL, you can access the web interface where it's possible to authenticate through the Cognito username and password or through the deep EM provider. In this case, we authenticate with the Cognito credentials. In the web interface, there are several sections where it is first necessary to select one of the available models. Once the model is selected, 2 information link appears. One with an example of the input file, in this case, an example of the body post detection model, and the other link is to the repository of the model to obtain more information about the model. The section to get the status of the job is only available for model running on AWS Bash that are long duration. For example, in the Darknet model that is in AWS Lambda, this section is not shown. There is also another section to review the input and output files in the bucket for the selected model. Okay, now we are going to proceed to load a file to see the output for the body post detection models, which is the one we have selected. Once the file is loaded in the input folder, we can see the file that we have just loaded. And in the job state section, we update and see how the job appears in runnable state. In this section, we have added an information link about the meaning of each of the state that a job can throw once it has submitted. Okay, this process might take several minutes and there is no provisional machine yet, so I will continue until I see change. After a few minutes, we see that there is already a provision machine and the job status changes to started. So we are there again, the job start is now running. Okay, the execution time, that is the approximate time from when the files begin to be processed until it is finished, is around 15 seconds. So we're going to do that again, and previously we had 3 jobs in succeed. Now, if we are there again, we can see that we have 4 jobs in succeed state, indicating that the job was processed successfully. In the output folder, we can see the result of the prediction. Also, this process took several minutes. If we have a provision machine and we will load another image, the process is more faster. The job goes directly to the running state After a few seconds, the process is completed. So we are going to date, and now we can see that the job is in running state. So we're there again. Okay, let's do it again. And maybe 50 seconds until we have the result. Now we have the 5 jobs in succeed state. In the output folder, we have the 2 results. From the web interface, it is possible to delete and download the files from the bucket. We are going to download one of the results, and we can see 2 files. Okay. Now we're going to open the folder. Okay, we have the output.json file that give us the result of the prediction in JSON format. And in the image, we can see the points marked by the prediction of the model. Okay, now, as conclusions, we can see that this presentation has introduced a serverless architecture to make it easy for users to invoke machine learning models through a web interface. The architecture uses AWS as execution backend, offering scale to 0 to minimize service operation costs. The proposed solution constitutes a step forward in simplifying the execution of artificial intelligence model by end users. Okay, in this slide, you can see the name and contact information of the author of this work. So if you have any question, you can contact with us. Thank you very much.
Thank you. Well, I think we've got one question here in the chat, but yeah, anyone, if you have any questions, please do put it in the chat or in the Google Doc, and I'll just take them in the order they appear. So the first question is from Lance. He's asking, the files used in this portal must be quite small. Has it been tested with video files or files greater than 4 gigabytes in size?
Hello, I will keep the video off due to the internet connection. So the portal have just tested with files because the implemented models only are available for files. So we can test it with video in the future, but just right now is do it with files and with the small files. But I think that it is because the limitation of the model, not because the platform. So we can test in the future other models and see how the portal will be with these files.
Did that answer your question, Lance? You can unmute if you want, if you have any follow-ups on that.
Thank you.
Right. Are there any other questions? Okay, while we have others maybe thinking of questions, I have a question, Diana. So, so I'm curious, what made you choose AWS? I know there's the whole Lambda and serverless compute, and you had mentioned being able to scale resources as you need, but do you have plans on using other cloud platforms or other resources in the future? What sort of pushed you to use AWS in this case, apart from the features that it provides?
Yeah, we use AWS Lambda because in the research group where I belong, we developed a tool called SCAR that allows us to create run applications packaged in Docker images on AWS Lambda. And in the future, we want to extend this tool to other platforms, so Google or Microsoft Azure. But just right now, this tool is for AWS Lambda, and for that we choose AWS.
Okay. I think we have time for one more question. Let me just check the Google Doc to see if there's any other. No. Okay, I have one last question. So how easy is it to add a new model to the platform if you had to maybe add a new say deep learning model or something else, or a new machine learning model? Is it designed to allow people to contribute their own models, or does there need to be some sort of administrative privileges that that are needed to do that.
Well, to integrate models.
Yeah, to add a new model to the platform.
Okay, just right now, the models that we integrated are from Deep Hybrid Data Cloud European project because they are integrated with DPAS. That is one of the tools that are important in this platform. So I think that a user needs to integrate the model with DPAS, and then this will be very easy because we develop a command line to obtain the prediction of the model through DPAS. So I think that first we need to integrate it with DPAS, and then everything will be easy.
Right. Well, thanks for answering those questions. I think we will have to move on to our next presentation now, but there's always time in the last 15 minutes if anyone has any more questions for Diana. Okay. I think our next presentation is also a recorded one. This one is by Andrea Zonka on deploying Kubernetes and JupyterHub on Exceed Jetstream.
Hi, everyone. I'm Andrea Zonka from the San Diego Supercomputer Center. I'll be presenting the paper Deploy Kubernetes and JupyterHub on Exceed Jetstream for the Gateways 2020 conference. First of all, I want to thank Catherine Lawrence for organizing the conference. It's a great pleasure to be part of this community and this conference every year. The link to the slides is available here on the first slide. And this work is a collaboration of different people across many institutions. So first of all, of course, me and Bob Sinkovitz at the San Diego Supercomputer Center. And then most of this work originated from ECSS consultations. So when you apply for a location on an Exceed supercomputer or cloud resource in this case, you also get assigned, if you want, a consultant that can help you out. So I started collaborating with Richard Signal and Julius Chastang as part of this collaboration. This brought to this work. And if you want to know more about ECSS, here is the link. And also, I got a lot of support from Jeremy Fisher and Mike Lowe directly they are part of the Jetstream team. And as I was a bit pushing the frontier on what was done on Jetstream, they helped a lot making this possible. So the objective of this work is to provide Jupyter notebooks to a large number of people. So we want to allow people to just be able to access a computational environment with pre-installed software and with significant amount of resources just by logging in through their browser. And this is suitable for a class, a workshop, or for a scientific collaboration, or for just any community. And fortunately, the Jupyter team has already a project which is doing this, which is JupyterHub, that allows multi-user access and handles authentication, monitoring of all the single-user sessions, and so on. And we want everyone to have enough memory and enough computing power. And so we cannot deploy on a single machine. We need the distributed system. And of course, this is more complicated. And also, what we want to do is we want to make it easier for US academics to be able to deploy this. And US academics a lot of them are already familiar with Exceed, so they can apply for an allocation. And in particular, they can apply for an allocation on Jetstream, which is a cloud resource, very much like the Amazon, Google, and Microsoft clouds, where you can request an allocation. And with that allocation, you can spin up virtual machines in the cloud, and then you have full control over them. And also, we, of course, want to have a system which is automatically resilient and then and can provide additional functionality, for example, logging, monitoring, and so on. And Kubernetes is a great system to provide this. And also, so the allocation on Jetstream is free, but of course it's limited. So we want to make sure that we are not wasting resources. So we want to use our resources just when needed. So we want to be able to scale both manually. So for example, you want to be testing your deployment with very few instances and then scale up when you actually have your user coming in. Or even better, you want to do automatic scaling. So when there are users connected, then there is more requests, you scale up, and then once user disconnect, you can scale down. And fortunately, to achieve all of this, we are standing on the shoulders of giants. So we have the Jupyter team also provided this zero-to-jupyterhub project, which provides a cloud-agnostic recipe to deploy JupyterHub. And so this works on Amazon, Google Cloud, and so on, and has extensive documentation. And this allows you to install all this complicated distributed system on top of Kubernetes. But first, we need to have a Kubernetes running on Jetstream. So in this paper, what we do is we give an overview and motivation of why you would want to deploy this and how the architecture works. And we provide an introduction to actual step-by-step tutorials. So we have step-by-step tutorials that are available on my website, and where people can follow these instructions, get all the configuration files that are needed to easily deploy first Kubernetes, and then on top of Kubernetes, have a ready functional installation of JupyterHub through a custom configuration for zero-to-jupyterhub. Let's take a look now at the architecture of the system. So first of all, we have some virtual machines on Jetstream. So on Jetstream, it's a cloud resource, so you can either through a web portal or through the command line, and this is what we will be using to deploy this. We can request virtual machine with a number of CPU, with some specific amount of RAM, and this is distributed across the Jetstream system. And on those virtual machines, we can deploy a Docker environment. And so we can imagine we have these Docker environments on the different machines. And Docker allows us to deploy containers so that we have a lot of flexibility. We can deploy, for example, if the virtual machine is running Fedora, we can have containers having Ubuntu or any other Linux distribution. And now those Docker environments are independent. So what we do is we install Kubernetes, so that Kubernetes installs different services across the cluster to basically manage in a easy way all of these distributed systems. So we can deploy containers somewhere in the cluster using Kubernetes. We can monitor them, look at the logs, and make sure that each container has a preset amount of CPU and RAM resources. And then we have, of course, this on our administrative system. We are able to manage all of this remotely with a very clean interface. And once we have Kubernetes, we can set up services to run on it. For example, we want to have a web server, so NGINX is a web server, and we can have it deployed as a container somewhere in this cluster of machines. And then a user can connect with their browser to this cluster of machines and have web page served. Okay, and we can have, but this same container could run on a different machine, and Kubernetes handles all of the internal networking. So basically gives you an abstract interface where you can handle those resources without having to worry where those resources are actually running. And so using this and following the tutorial that I'm presenting here, you can first deploy Kubernetes on Jetstream, and then you can deploy JupyterHub. So once we have a full JupyterHub deployment running, what you have is you have your JupyterHub instance, which is running, and whenever a user connects with through their laptop on this instance, they are redirected for authentication, and this system can easily support Google, GitHub, Xseed, or even CI logon, so you can use your institution credential to log in. And then the users are redirected back to this instance, and a single user instance of the Jupyter Notebook is started as a container somewhere in this cluster, and each user is assigned a number of CPU and an amount of RAM that they can use. And also we automatically handle persistent volume for them. So Jetstream allows to create on the fly specific volumes for each user, and so we mount those volumes where the single user notebook is running, and once the user logs out, this volume is automatically unmounted, and then whenever the user logs back in, this volume is mounted on another instance where they are running this time. And so we have multiple users that can use this interface, and it's very easy for them, because they basically just see the notebook running inside their browser, so they don't they have no vision on all the complexity of the architecture beneath this. They just have the simple Jupyter Notebook interface that they would see if they were running on their laptop, but now they have all the power that we can give them, and they have a centrally managed software environment, which is very powerful. And we can also, this system also supports auto-scaling. So what happens is that if some users log out, and we have some workers that are not doing much, so there are no user instances, that we are basically wasting resources. So once we deploy the autoscaler, those empty workers are automatically decommissioned. And whenever there are new users that log back in and there are not enough resources across the cluster, then we can create new nodes and have them attached to the Kubernetes cluster. And on top of this, we also have several other tutorials. So we have, of course, we want to set up autoscaling, and then we have other things that you can take a look at here. I want to just note, for example, deploying Dask gateway is really interesting, because you can deploy Dask so that on top of using your single user Jupyter notebook, you can connect to other workers that are running Dask. So you can use distributed computing inside Kubernetes. We have deployed this in real-world situations. So the largest deployment as of now was done by Julian Chastang at the American Meteorological Society meeting in 2020, where he deployed 40 virtual machines and had 130 students go through a Python workshop on this system. And then he also deployed a lot of systems for classes, and then you see there are other applications below. So thank you very much for following this. So at this URL here, you can find links to the step-by-step tutorials, to the paper, and also to a 1 hour long tutorial that goes more in depth about this. And if you want to try one of this and you find any issue, please take a look at this repository where you can open a ticket.
All right. Well, that was a really interesting talk. Thanks, Andrea. And I know you've been answering questions here in the chat, but I'll just go over them real quick so people have a chance to do if they have any follow-ups on that. So Lance initially asked what were the resources assigned to each session. So each Jupyter Lab session that's set up for a particular, I think, set of users or for a particular use case. And then, I don't know, Andrea, do you just want to briefly talk about it? You can unmute and talk about it.
Yeah, I can just give a summary of what we were looking at. So the idea is that we want to configure, have the user being able to configure their job. So if they want more or less resources. And there are different ways. So if we are on Kubernetes, as in my tutorial, then Spawner has support for that. So it's very easy. You just define a few different configurations, and then the user can choose when they after they log in, they can choose from a drop-down menu, basically. And there is a screenshot linked here. So if you want to take a look at how that looks like. And otherwise, there is a dedicated spawner, which is called wrap spawner, and that basically works. That it's even gives you actually more flexibility. So you could have different kind of spawners so you not only you can choose between different resources on the same type of spawner, but you could have different spawners running at the same time. So you could have, for example, a spawner that spawns a job on a supercomputer, and instead a spawner that just runs locally, for example, if you don't need that many resources. And then you can wrap them with wrap spawner so that the user can choose whether they want to go to an HPC node or just run locally.
Okay, got it. Thanks. I think we have time for one more question. Okay, let's see if I don't see any new questions here in the chat, but I'll ask one. So this was just bare bones Jupyter Hub, right? So if you're using, so maybe for in the NCAR case, maybe you have like a couple of GIS libraries or something that need to be loaded in to the Jupyter Hub. So how do you, what's the best practice there for including maybe like, do you have like different kernels for the specific science libraries, or how do you incorporate that into the installation?
Yeah, so one of the configuration options for Jupyter Hub is the container where the users want to run. And so that's the easiest way. You customize the container. And so you can have all of your software packages, and then you can also have Jupyter Hub check if that container is updated so that you always have the latest version of that. And another option that I've explored is to use CVMFS, which is a distributed software distribution tool. And so with CVMFS, you can basically have a kernel which is running through CVMFS. And so that you basically handle out all the software environment to CVMFS, and so you're not maintaining that into Jupyter Hub anymore. So whatever you're doing for other users for HPC centers, you can also use inside Jupyter Hub, and I have a tutorial on that. I'm gonna paste it into the chat.
Awesome. Well, thanks, Andrea. Unfortunately, we have to move on to our next presentation now, but we can get to more questions again in the last 15 minutes. So our next talk is by Joe Stubbs from TAC. He's going to be talking about enabling science with functions as a service, new features, and usage of the Abaco platform.
Okay, awesome. Thank you very much. Yeah, so my name is Joe Stubbs. I'm at TAC, and I'm going to be talking about a functions as a service platform that we've been developing there called Abaco. So just a brief acknowledgement, this is funded by the National Science Foundation, and I also want to thank my colleagues and co-authors on the paper here. So just a quick overview of the outline. Gonna just briefly talk about functions as a service, what that is, and introduce the basic usage of Abaco itself. Talk a little bit about the use cases that we see for science gateways. Say a little bit about what we've been doing with Abaco over the last year and a half or so in terms of new features, and then kind of close with a few science highlights from the usage. So I think there was a nice presentation in the first talk about using AWS Lambda as functions as a service, and probably lots of people are familiar with the concept, but I wanted to kind of give a quick overview for those who may not be familiar. So with functions as a service, basically what you do is you create this small unit of computation called a function. You can think of this as like a little program, and you register it with the FAS platform. Then once it's registered, you can send requests to the platform, instructing the platform to execute that function with certain inputs. So in the end, these functions end up running on the remote platform, right? Not on the developer's laptop. And that's where this term serverless comes from, right? It's you know, the developer isn't providing any servers, but of course there's servers involved on the platform side. So with Abaco, which stands for Actor-Based Containers, what we have is a functions as a service platform where the functions are packaged as Docker containers. So you build your functions in Docker containers, and then you interact with Abaco over HTTP. So Abaco incorporates the actor model of concurrent computation, which is why we refer to the functions as actors. I'm not going to go into detail about the actor model itself. It's not really necessary to know anything about that to use Abaco. But you know, Abaco started as a prototype in late 2015, and then became funded by the National Science Foundation in 2017. So we've been in production a little over 2 years now, and we've done almost 1 million executions, about 24 million seconds of total function runtime in that time. So yeah, so the basic usage, you know, what you do is you take some program, some little computation that you want to do, and you package it up in a Docker image. You push that image to the Docker Hub or any other publicly available image registry. Then you register that image as an actor with Abaco, and that's just a post request to one of the endpoints inside the Abaco API. Once it's registered, Abaco will create for you a URL assigned to that actor. And then you can send that actor what we call messages by making a post request to the URL assigned to the actor. Now, once that happens, once you've made a post, internally what Abaco is going to do is it's going to queue that message in a message queue assigned to the actor. So for each message, eventually what Abaco is going to do is it's going to run a container from the image associated with the actor, and it's going to inject the message data into the container. It's going to supervise the execution. And so while it runs, it's collecting resource utilization, container logs, other kinds of data, and exposes that through other endpoints. The other thing to say about Abaco is you can update actors, you can delete them, and you can also share actors with other users at a specified level. So there are kind of two primary types of use cases that we see for Abaco. So on the one hand, you can just kind of think of Abaco as a task queue abstraction, right? It's just tasks as a service. Any kind of background or asynchronous processing that you want to do, you can send, you can package as an actor and you can run it on Abaco. So this could be anything from various things you need to do at account initialization when new users sign up for your gateway, to pre-processing and post-processing of files and other kinds of data that are coming into the gateway. So that's kind of on the one side. On the other hand, you can actually do scientific analysis, like was mentioned in the first talk. You can actually run AI image classifiers, right, and AI workloads, other kinds of analyses directly in Abaco. So the left side is really kind of defined and implemented by the CI experts, the web developers, and the programmers building the gateways. And the other side is traditionally defined and implemented by domain experts, the researchers using it. And so what we kind of think is cool, what we're hoping for, and what we've kind of started to see with some projects, is a sort of convergence of these two use cases, right? You can see with data pre-processing and post-processing steps, you can combine that with analysis to form sort of complete pipelines. And that isn't to say that all the analysis has to happen on Abaco, right? Abaco actors can make calls to submit jobs to traditional HPC systems and other kinds of platforms, but you can combine all of this into sort of a complete pipeline. And so Abaco provides this platform where domain experts and CI experts can collaborate together. It's language agnostic in the sense that any container, any Docker image can be used. And there are multiple patterns for combining the components, from tightly coupled, where actors send messages directly to themselves, to more loosely coupled, where things are triggered by events. And so, yeah, we see that as these things get integrated, it tends to reduce time to solution because there's this coherent pipeline. So this is the architecture for Abaco. I won't go into the details, but just to mention that we have a front end with web services. We have a back end set of workers, and then we have a persistence layer made up of MongoDB and RabbitMQ. And then we have this autoscaler that essentially watches the queue links and starts and shuts down workers based on which actors have messages that are queued up. So we've been working on a number of features since the initial production release of Abaco. That was in January of 2018. So the autoscaler itself is new. You can also manually scale your worker pool for a given actor that you have permission for. But we have this autoscaler. We've added support for doing synchronous executions. So typically when you send a message to Abaco, it just queues it up and it runs it at some time. But you can actually say, no, I want to run this as a blocking call. And so the whole execution will run as part of the HTTP request, and the response will come back with the result of the execution. We have added support for actor networks, a lot of different features for these complex networks, including an event subsystem, this thing that we call aliases, so that you can change actors in a network, change their definitions without impacting the other actors that call it, and then config objects for configuring whole sets of actors all at once. And then we've also added this global search, which is pretty cool. It gives you exact and fuzzy match search across all of our primary collections, including all the logs. there is a study. It was actually published in 2022, but performed pretty much in 2019, where we did a kind of deep analysis of the Abaco performance. It's published in GCC. I won't go into detail here, but we scaled it up to 100 nodes, 100 M1 medium nodes on Jetstream. And we did a mix of a bunch of different workload tests, including matrix multiplication and SHA-256 hashing. So we got about 19 teraflops of performance, and the big upshot was that the autoscaler was really negligible compared to manual scaling. So that was cool. So just a brief word on Abaco compared to other platforms. There are a lot of other functions as a service platforms out there. Obviously all the commercial clouds have them. There are a lot of open source ones as well. Abaco is open source. It is funded by the NSF. It is hosted at TAC, and it is free to use for researchers. So that is one of its distinguishing features. It does incorporate this actor model, which I didn't really talk about, but we think that that's really useful for building these networks, these more complicated pipelines of integrated functions. And then it targets the research computing case, right? So we're really trying to be a platform for gateways and the types of workloads that they run. So we integrate with TAC resources, things like the POSIX interfaces to high performance TAC storage, and also Jupyter notebooks for scaling functions from there. And with the next release of Abaco, what we're hoping to be able to enable is for institutions to run a subset of the Abaco components, just the workers, and leverage the AI, the API infrastructure hosted at TAC, and be able to run Abaco functions on premise at your own institution. So that's coming up next. So yeah, this is just some of the details. We have several projects using it. Some is just kind of a basic task queue, including our new UT Austin COVID-19 modeling consortium. Some are using it more on the sort of research side as an execution platform like DesignSafe and GenApp and Cyverse. And then we do have a couple of projects that are starting to use it with these really large networks, including the Synergistic Discovery and Design Environment, which is a DARPA-funded project, and then NUID out of NASA JPL. So yeah, that's it for me. There's a link to the docs on Read the Docs and to the GitHub project if you're interested in checking any of that out. My email there is there, so happy to answer questions. And yeah, if you want to learn more, feel free to join our Slack team as well there. Thanks.
Awesome. Thanks so much, Joe, for sticking to time. Yeah, so we've got close to 3 minutes for questions. If you have any, please put them in the chat.
I do have a question, and I missed a little bit at the beginning. So is this a TAC specific service? And so the containers and the actors actually run on TAC, is that correct?
That's correct. Yes, exactly.
Okay, thank you.
Yeah, so it's TAC specific, but really, the people using it are all over. Lots of different collaborators from different institutions. So it's running on TAC infrastructure. For now, we have some organizations that are interested in standing up, parts of the system and running functions on their infrastructure. So hopefully by this time next year, we'll have a few examples of that as well.
So it's, in a way, that was a really neat talk. In a way, this is a gatewayless gateway, right? This is just the insides, correct?
Yeah, exactly. That's so nice that you brought that up, because one of the inspirations for this was these sort of serverless gateways, where you could have a gateway that just lived on Google Drive, right, or Dropbox. Right, or any really content delivery system where you just had static files, and the idea there was you just bundle up some JavaScript and CSS and image files, and you can have a pretty functioning gateway. But you need an API, or you need something where you can, usually you need something where you can queue up backend asynchronous tasks. And so we thought, with this, you could eventually realize this idea of this truly serverless distributed on Dropbox gateway. And so we do have a couple of folks in our web team that are kind of looking at doing something like that. It's not quite ready yet, but that's our hope.
Very cool. Is this the API that your Tapas gateway uses, or this is a different beast?
Yeah, thank you for bringing that up too. That's a great question. So we are integrating this with the newest version of Tapas. So it will be so there will be a functions endpoint inside Tapas v3, the version 3, and it will just be this. It'll really just be Abaco. We actually just pushed that to our kind of beta for v3 a couple of days ago. So so you can combine it with the streaming API that's there in Tapas v3 and some of the other APIs. So yeah, that's kind of the relationship. It'll ultimately be just the functions API inside Tapas.
Great, thank you.
Thank you.
Great, those were really interesting questions. I do have a final one. We're at 3:15, so the next 15 minutes is kind of a mini panel where I'm hoping to have, I guess, everyone here answer some questions. Well, the three presenters answer questions, but maybe I'll start with Joe and then kind of move on to the others. So this is more of, I guess, Abaco specific question, but maybe more general as well. So these functions that you're designing, so what are sort of the, I guess, the design patterns or the constraints? Because you have things like side effects. I don't know if you have to worry about side effects that these containers are going to be introducing, and especially when you have the whole actor model with the network, how do you ensure that the next function in the chain sort of runs only when you expect it to run? So what are some of the design patterns that someone might need to follow if they're designing functions?
Yeah, okay, that's a great question. So these are generally speaking not pure functions. They do have side effects. Mm-hmm. One of the big common use cases is that we have somebody has some big directory of data files, and they just mount them as POSIX, mounts into the container, and they do some churning through that stuff, right? So there's all kinds of side effects happening there. The patterns. So the patterns are kind of I would say two main ones. There is direct messaging. So I have actor 1 and you have actor 2, and I don't, actor 2 doesn't run unless I call you and I say, look, I did this, it's done, it's ready, and I send you a message and now you run. That's kind of a direct, kind of tight couple. And then the loose couple is events, right? So when something happens in Abaco, like an execution starting or an execution finishing, it's an event. Mm-hmm. And there are mechanisms essentially for having those events trigger other functions, trigger other, basically you can send, you can tell the system, I want this actor to receive this message whenever this event happens. Mm-hmm. And so that's kind of a loose coupling. You say, oh, that actor must have just finished, so that means it's it's my turn to do whatever. Right. I don't know if that answers your question.
No, that answers the question. Yeah, and okay. That sort of just leads me to maybe the broader sort of question for all the three presenters regarding like what's the barrier to entry here? So are you expecting these to be primarily gateway developers and CI experts who are building these things, or do you expect the community to sort of contribute to these projects? And that's a question for all three of you, Joe, Andrea, and Diana. So what's sort of especially with these new technologies, what's the barrier to entry if you expect your science teams want to either understand what's going on or the overhead that's involved? And if you expect them to be actively contributing to it, what are some of the issues there? And anyone of you can jump in if you want to go first.
Yeah, maybe I can start. Sure. So so the deployments of Kubernetes and JupyterHub on JetStream, the target is mostly for administrators, and so the tutorial that I posted online, they are quite easy to follow. So I had, for example, a group that was just trying to follow the tutorials as better. And then what they did is they had some trouble here and there, so I helped them out a bit with troubleshooting, and then they applied for an ECSS allocation. They applied for an exceed allocation, and they got ECSS support. And then now I can help them directly. So basically, they jumped in just looking at what's available online, and then they went through the process of actually going through an ECSS consultation. So. But you need an help from an expert. So either you are an expert yourself, or you get an expert through ECSS.
Right. And Diana, I know we talked about briefly before on how you could add new models to the platform. So do you want to expand on that and talk about just maybe the barriers for other people to start using either the platform or contributing to it? And then we can encourage you on.
Yes, I think there is a good opportunity to collaborate on this project because the integration of machine learning models in cloud computing, and especially in serverless computing, allows to facilitate the inference phase of machine learning and artificial intelligence models. So in this platform, the integration of a model, I say before that we need to integrate it with the bus, but we also can have our model in a container and have a command line, and with that we can integrate it with the SCAR without using the bus. So the main component of this platform is a SCAR that, like I said before, is a tool to integrate or to run Docker applications package in Docker imaging. So I think that this is a good opportunity to the world of machine learning, and especially to the users, to make it more easy to make easier the integration of this model in the cloud computing.
Got it. Thanks. Joe?
Yeah, I mean, so we have people contributing, writing actors with different backgrounds. We have, people who have a more kind of like web developer background, and then we also have people who have more of a research, domain science background. But I would say that all of them have some programming, expertise. They do need to be able to say write programs in Python. They need to be able to work with Docker and you have some familiarity there. As far as contributing to Abaco itself, we have it's written in Python, and so that is more kind of the web distributed systems type. You need kind of that background to contribute to it. But we have people who run the functions through gateways through point and click. So they're consumers who are not they don't have any of that knowledge and can use it. So I don't know if that makes sense, but yeah.
Right. Yeah. I think that makes sense. Yeah. And I guess it's just maybe completely different communities. Well, maybe at least initially it's completely different communities who are doing the different things. And as Andrea mentioned before, once maybe you get them using the platform and seeing how easy it is, then you can, I guess, motivate more of them to start contributing to some of the backend as well. All right.
Absolutely.
Yeah, and if anyone has any other questions, please put them either in the chat or the Google Doc, and we can take them as well. But maybe my next question that you can all think about is, so with containers, I mean, obviously there's a whole lot of things that it's enabled now, just with being able to package dependencies, run things in like a scalable fashion wherever you want. But what's the one thing that you still have issues with that, or maybe the one thing that's maybe on your wish list with containers that you wish would be implemented so you can do much better things? And it can be really specific too. I mean, so it could either be like just storage and volumes, or maybe it's I don't know if it's dependency management or just container recipe management, because I know there's things like the NVIDIA HPC container maker. I don't know if any of you are familiar with that, but that sort of helps. I think at least it tries to have a much more higher level container recipe than the typical Docker file or your Singularity recipe. So I wonder if there's things like that that you think might make your jobs a little more easier than just building containers. Or is it more of just once you've had your basic recipe done, then everything is just sort of incremental on top of that?
Well, I can go. I think that, the security implications, if you will, issues around using Docker is one challenge. So in Abaco, we use Docker containers right now. We are also working on expanding that so that it can use Singularity containers, where you have a bit better situation, right, in terms of the permission escalation situation. And of course, you have it on all the major, or at least most of the major, HPC systems. So we're trying to do that, but it's still a bit like trying to bridge two different worlds. And and Singularity is leading, but it's also not the only kind of user space container runtime, right? There's Charlie Cloud, there's Shifter, there's a bunch of other ones. And so it's kind of a lot more fragmented over on that side as well. So it's kind of like you have Docker, which really has a lot of traction, and you can write to that. But then you have the sort of permission escalation issue. And then on the other side, there are all these kind of promising technologies, but there's a lot of work that you have to do to kind of translate between them. So that's the one challenge that I would like to see, go away for me, in the next, so often.
Yeah. Andrea, do you have any thoughts on that?
Yeah, no, so I think it's easier for my work because I'm already working in a cloud environment. So security is not a big issue for us. So because everyone has their own separated Kubernetes cluster, and usually those platforms are small platforms used by just a limited amount of users, or other times maybe especially when there are a lot of users, oftentimes they're maybe just deployed for a workshop or for a tutorial at a conference, and so they are just temporarily deployed, and then after a few days they are just decommissioned. So in those environments, security is not a big issue. And about Docker itself, I think that currently the state of Docker is pretty good for using it in a cloud environment. So because so we're not trying to adapt Docker to other environments. So we are in its own native environment. So it's pretty good. And and the best thing I think is Docker Hub, where you can set up your containers to automatically build from GitHub. And so people basically don't even need to, when they have maybe to update a package or to add another Python package to the Docker container, they can basically just go on GitHub, edit the Docker file there, and automatically this is built on Docker Hub. So they don't even have to build the containers on their machine, but they can have it handled between GitHub and Docker Hub. And if there's any build errors in the build, they can look at the logs there. So I think that the workflow is very nice.
And Diana, did you have any thoughts on what's probably the main pain point for you so far with containers, or just integration with the AWS Lambda?
Yes, as Joel say, I think one of the biggest limitations of Docker is security issues. In our case, the containers are executed in Lambda functions, and we don't take this limitation into account. But We use uDocker as a tool for executing Docker imaging in user space, since in Lambda there is no root access, and which make it a limitation in use of Docker.
Got it. Unfortunately, I think that's the end of our session today. Well, thanks everyone for joining us in this session on containers, and thanks to Joe, Andrea, and Diana for their really interesting talks. So I think there's a break now, and then the next session is the Learning Labs, and you can learn more about them either in the schedule or in Kiko on the left, on the panel on the left. But thanks everyone, and have a good rest of your conference.
Thank you.
Thank you. Bye-bye.